Okay, we are going to finish the sample AP Precalculus questions given by the College Board, the multiple choice portion at least, and we are on the graphing calculator required portion. So there's about 5 problems, or only 5 problems, so it should not take too long. So let's get started. Let me also pull up my graphing calculator real quick on my phone. All right, temperature in degrees Celsius in a city on a particular day is modeled by the function t given by the sky, where t is measured in hours from 12 p.m. t is between 2 and 9. Based on the model, how many hours did it take for the temperature to increase from 0 degrees to 5 degrees? And so I would just graph this in your calculator and see where it crosses 0 and where it crosses 5, and find those values of t or x in your calculator and find the difference. Okay, so let me do that real quick. Okay, so it looks something like this. Hopefully you can see on camera. Okay, so this is our function t. Okay, we want to see where it crosses t, capital T is 0, or y is 0 in this case, and in my graph, y is 0, if this is equal to y, let's say. Well, crosses y is 0 and y is 5, because that's where we want the temperature to be, the values of the temperature to be, okay? So we're just going to find the points of intersection. So over here, it crosses y is 0, 1, x is 5. Let's write that down. So when t, in this case the original variable is t, 5.420253, so let's call that t1. t2, where it crosses 5 degrees, would be this point up here. So t is 7.700724. So we just want t2 minus t1 for the hours it took to increase from 0 to 5 degrees. So what would that be over here? Well, we can even just eyeball it. It should be like 2 point something, right? So the only answer is D over here. Okay. Table presents values for a function f, a selected values of x, an exponential regression y is a times b to x is used to model these data. What is the value of f of 1.5 predicted by the exponential function model? So you got to plug these points in your calculator and then use the exponential regression function in the calculator. So luckily my app can do that also, so let me do that. Okay, so if you graph the points, it looks something like this. And then you apply an exponential model. So I got over here. So let me write down what. So if we use the term y is a times b to x. Well, when you use an exponential model, it is going to be in terms of e. So that's what my calculator over here even, right? So it should be, okay, well, let me just write it as y is 24.076, 027, let me write all the decimal points, times e to the 0.442636x. Okay, so this is our exponential model. Okay, it looks a little different than this, but maybe your calculator is more advanced and can do any base of the exponent, but commonly you just use the e. But we can always rewrite it. We're not interested even in the a and b, so we can keep it like this actually. But if you really wanted to write it as a and b, well, you can rewrite this as 24.076. I'm going to just truncate for the purpose of saving time. E to 0.443, e to the x. And then this term would be your a, and b would equal to e. It's the same thing, right? So you could write it like this, but we don't need this actually, okay? So we are interested in f of 1.5. So we just plug in y of 1.5. Okay, so let me plug that into my calculator. 24.076027 times e to the 0.442636 times 1.5. So I get that it's 46.767, something like that. So the answer is A. Okay. So once again, you just use your calculator to find the exponential model. We are not interested in the A and B, so you could just keep it like this if your base is E. If we were interested in A and B, then we could rewrite it like this. This would be your A and your B would be E. But it's the same thing, right? So we can just plug in 1.5 as x into our model, and that gets us our answer. Number of minutes of daylight per day for a certain city can be modeled by the function d given by this guy, where t is the day of the year for t is between 1 and 365. Which of the following best describes the behavior of d or t on day 150? So let's graph this in our calculator. Here you got to be careful about setting your window probably. So you got to know that, well, this cosine is shifted up by 729. So you got to look like way up. So maybe set your limit to y limits to like, well, the amplitude is even 160. So maybe it's like 500 to 1,000 or something like that, if you really need to see where it is, okay? So here, once again, the important part is not just graphing this in your calculator, that's easy, but you have to set your limits appropriately, your window appropriately to view this function, right? So let me graph this on my calculator. Okay, so with my calculator, because I can just change my window really easily, but if you had to type your limits, then once again, as I said, you gotta know that this is shifted up by 729, so you can see like the average value is around 700 something, right? And the amplitude is 160. So I know basic things about your amplitude of a sinusoidal function, all right? And then the period would be 365, I think it looks like, right? Because it'll be 2 pi over 365, so it's 365. So you gotta set your window appropriately, as I keep saying. All right, so now we're interested in what happens when it's day 150 or t is 150. So when it's 150, if you can see on my screen, it'll be somewhere over here, right? So what about that point? What did the choices say? Number of minutes of daylight is increasing or is it decreasing? Well, clearly it's increasing, right? The function's increasing. So we can eliminate b and d already. Okay. So is it increasing at a decreasing rate or increasing at an increasing rate? So if you remember in the previous problem, in the no calculator portion, this is related to concavity. So is it concave up or down at 150? It's concave down, right? So it's increasing at a decreasing rate. So it should be A. Okay. Function g is given by g of x is sine x minus cosine x, has a period of 2 pi. In order to define the inverse function of g, which the following specifies a restricted domain for g and provides a rationale for why g is invertible on that domain. All right, so let's graph this guy first. Let me quickly do that. I won't pause the video here. It'll be what? Sine x minus cosine x. Okay, so I'm trying to set my limits appropriately now. All right, so it looks something like this. All right, so in order for it to be invertible, it has to be 1-to-1. Remember, there's a simple test for that. It's the horizontal line test to make sure that the inverse exists. So we're going to restrict the domain of G such that the horizontal line test passes, okay? So from 0 to pi, that would be from here to here. Does the horizontal line test pass? No, because when we draw a horizontal line over here, it'll cross like 2 points within 0 to pi, right? Especially like right here. So this would not work. Okay, how about negative pi over 4 to 3 pi over 4? Negative pi over 4 would be somewhere here, right? This is negative pi over 2, so negative pi over 4 somewhere here. And then 3 pi over 4 is just short of 4 pi over 4, which is pi, so it'll be somewhere here. Okay, so it looks like that might work, so let's hold off on that. How about x is between 0 and pi? Oh, we just did that over here, right? It fails the horizontal line test. And this is the same interval as here. So, okay, now let's look at the rationale. Because all positive values of g occur without repeating on this interval. That's likely it. Length of this interval is half the period. If it's half the period, it doesn't matter. And I could think of a counter example right away where this would not work. Okay? So it doesn't have to do with the period. It has to do with it being 1 to 1, meaning there's only one value. Right? So it's B. Okay, now as for this guy, it's not exactly this function, but I can draw you something where, like, for example, if it's like this, so the period is, this is not a great sketch, but the period is here, right? Half the period is here, something right like that, right? So let me draw a solid line here. Half the period is somewhere here, but you can see, even within half the period, it doesn't pass the horizontal line test, right? So this is not a good reason. So this is for sure the reason, though. So the answer is B. Okay, and the last problem. Theme park thrill ride involves a tower and a carriage that rapidly moves passengers up and down along a vertical axis, as shown in the figure. Carriage is lifted to the top of the tower, then released to move down the tower. The ride involves 10 controlled bounces from the highest point to the lowest point and back to the highest point. A point X is located on the bottom of the carriage. The height of X above the ground can be modeled by a periodic function h. So X is over here at this point, okay? At time t is 0, X is at the highest point, 120 feet. The lowest point of X is at a height of 20 feet. The next time X is at its highest point is at time t is equal to 8, which is the end of the first bounce. Which of the following can be an expression of h where t is time in seconds? So there's lots of unnecessary info that this word problem gives you. So the only key points are, by the choices, it's the sinusoid. So we want to know the amplitude and the period of the sinusoid. Okay? There's also some shifting also, but we can easily figure it out. The key points for a sinusoid are the period and the amplitude, the frequency and the amplitude you can even think of. Okay, so let's see. The next time it's at its highest point is t is 8. So that tells us the period is 8. So how do we find the period of a sinusoid? Well, when we have like sine or cosine of omega t, the period is 2 pi over omega. Okay, so the period is 8, we said, so that would be 2 pi over omega. So omega would be 2 pi over 8, which is pi over 4. So we can eliminate C and D already. Okay, now is it sine or is it cosine? So this is where the amplitude matters now, all right? At time t is 0, X is at its highest point of 120 feet. So when t is 0, for choice A, sine of 0 is 0, so it would be at height of 70, which is not 120, so we can cross that out. When t is 0, it will be cosine of 0 is 1, so 50 plus 70 is 120, so the answer is B. As simple as that. Okay, so they tell us, why would we care about time-controlled bounces? It doesn't have to do anything with the thing. All right, the lowest point we could have checked also, so when in this period, we know that cosine is between -1 and 1. So when cosine is -1, we get -50 plus 70, which is 20. So that matches that, right? Okay, so that's it for the multiple choice. Hopefully this was helpful and just seeing how I think about the problems and all that. Please like this video if you did find it helpful, and please also subscribe if you haven't already, and you'll also get notified for the free response when I post that. So I'll see you in that video. Bye.